Hello BCSD third graders, it's Mrs. Whitman with the May 7th math task. There are 5 nests in a chicken coop and 2 eggs in each nest. If the farmer wants 25 eggs, how many more eggs does she need? All right, let's work with the information that's given in the first sentence to start us off. So it says there are 5 nests in a chicken coop and 2 eggs in each nest. So that's sounding a lot like a multiplication problem so far. It's kind of sounding like equal groups to me because 5 nests could be the groups that we are working with. So 1, 2, 3, 4, 5 nests. And then if we have 2 eggs in each nest, then I'm going to just put those 2 eggs in each of the groups I just made. So I'm going to go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, and that's what she has in her chicken coop already. I count 2, 4, 6, 8, 10. So she's got 10 right now, or 10 already. But it says if the farmer wants 25 eggs, how many more eggs does she need? In general, the statement how many more should make you think subtraction. That's the type of math that we're doing here. Okay, so if she's got 10 already and she wants 25 total, then I need to do 25 minus the 10 that she already has to find my answer. So that means she needs 15 more eggs if she wants 25 total. Okay, I'm going to move on to the next page real quick, where it says show 2 ways of subtracting 762, bless you, minus 239. There's, a lot of different ways that you can show subtraction. 2 ways that I like to do in my classroom are I like to do just the generic algorithm, meaning lining your numbers up with ones, tens, and hundreds. My daughter's playing right next to me. Sorry if that's kind of loud. Oops, what's going on here? My pen's not working all of a sudden. There we go. Okay, so this is the standard algorithm or the standard practice, old school way of subtracting. I'm going to look in my ones column first, and I can't take away 9 from 2. I have to go next door. So I'm going to go to the tens place, and I'm going to regroup. That becomes a 5, and I regroup, and that becomes 12. So now I'm going to do 12 minus 9, which I can do. That's 3. 5 minus 3 I can do, that's 2. 7 minus 2 I can do, that's 5. Okay, so that's my answer, but it says show 2 ways of subtracting. Another way that I don't think I've ever highlighted on here is using expanded form for subtraction. Let me show you how that would work. First, I would write my numbers out in expanded form. And I do have another video in the second packet that highlights with a little bit more explanation how to do expanded form. And actually, I should not have put a plus sign there. Okay, we're going to do subtraction, and I'm really emphasizing my subtraction sign here because it's kind of easy to get confused when you use expanded form for modeling subtraction, because you still have to write those plus signs in between your ones and tens and hundreds values that you just wrote. So I really darken that subtraction sign to remind myself, okay, even though it looks like addition because it's written in expanded form, I still have to do subtraction. Okay, so just like before in the standard algorithm, let me write that so you can see what I'm talking about. This strategy is the standard algorithm, or the old school way, as I like to call it. Okay, now this other way with the expanded form, we start off the same way. I can't do 2 minus 9. So I've got to go next door. Then I'm going to take away 10 from my 60, and I'm left with 50, which gives me a 10 to put right there. Okay? That I'm draw an arrow just so you can see where that 10 went. So that means I'm doing 12 minus 9 now, and I know that's 3. Now I'm going to do 50 minus 30 right here. That's 20. I'm going to bring down those plus signs that I had for the expanded form, and 700 minus 200 is 500. Now to get my final answer, I just add those straight across. All those numbers added together are 523. So I have just proven 2 different ways, with the standard algorithm being one way and expanded form strategy being the other, the answer for this subtraction problem. Okay, moving on to the last bit. What number should be placed in the box to make the equation true? Explain how you found the missing number. Okay, whenever there is a missing addend in an addition problem, the easiest way to figure this out is by rewriting it as a subtraction problem. And you'll see this actually in my math explanation for May 6th. We also had some problems like this. So if you want to see another example, check out the May 6th math explanation video. So I'm going to rewrite this, and I'm going to do 230, and I'm going to do minus 160. Okay, so I take the answer goes on top, and I subtract the addend that I have. Now, when I get this answer, that's my missing addend. 0 minus 0 is 0. I can't do 3 minus 6, so I have to go next door. I'm going to take that 100, put it over here, and that becomes 13. I'm going to use a different color just so that it's easier to see where that went. There we go. Okay, 13 minus 6 is 7. So my answer should be 70, okay? Because 1 minus 1 is 0. If I put the 70 there, I'm just going to double check it real quick. 160 plus 70, 0. That's a 13 right there. And 230 indeed. All right, just in time because my daughter needs me. I will talk to you later. Bye.